So my latest project here is changing the motor on my snowblower. This one here, of course it looks pretty rough because I have everything torn off of it. A lot of it's in the scrap barrel by now. But this is one of these motors that no matter what I do to it or for it or say to it, it just will not run reliably. I bought it secondhand years ago and I have used it off and on. I made another video on I think some sort of a strainer, gas tank strainer I made for it. But I just can't keep the thing running right. And I got tired of dealing with it every winter of it. You know, I end up having to go to the snow shovel pretty much all the time. And so I decided to get a new motor. And this is a Kohler 6.5 horsepower, 10 foot-pounds of torque. This is an MTD Powermore, and a Powermore is actually MTD's own engine design that they have made in Asia. I don't know if they still do that or not, but this is a 2008. As far as I know, the like 2015, 16, I think they were still making these things, and people invariably talk about how they're always running too lean and how they kind of struggle to get them to run properly. And that's one of the reasons that I just got a new motor instead of getting an entire snowblower. A couple people asked me, he said, why don't you just get, you know, the snowblower instead of buying a motor and putting the money in it? Well, the snowblower itself, even though it's not really pretty, it's actually mechanically sound. And if I was to get a snowblower, unless I was to get a Honda, which is, you know, you're going to pay a lot just for that motor, you know, unless it's like the Honda snowblower, they're probably, if it's an MTD model, they're probably going to have something like this again, and I don't want to go through dealing with this because they're saying that even right out of the box, these things, some of these, you have to put them on half choke just to get them to get enough gas into the motor so they run. That's one of the problems I was having with this, one of the problems. But all the problems had to do with gas starvation in one form or another. So Kohler is a good name, as you know. I have one of these in my tractor. I have a big V-twin in the tractor it's basically like starting a car engine. It's very smooth and reliable, and I just had good luck with it, like I've had with most engines like Briggs and Tecumseh. I never really had a huge issue with any of them. What I need to do with this one here to transition from this one to this one is to either make the pulleys work that come with the original engine, or make new pulleys, or find off-the-shelf components. This is 179 cc's. This one is 196 cc's, 6.5 horse and 10 foot-pounds of torque. And this one here, of course, will have no problems whatsoever. At least I'm not anticipating any. So as far as the pulley situation, I wanted to originally take these factory pulleys here and just make an adapter to go onto the smaller output shaft, but any adapter would have been very thin wall thickness, like a 1/16 of an inch, which is not enough, and there was other complications involved with the keyway. So I have this one pulley here. This pitch diameter already matches the pitch diameter of this here. In other words, the pitch diameter is like the effective diameter where the belt would sit. It's an A section or a 4L belt. So I compared these. I measured over pins on these and found that they're almost the same pitch. So that, you know, so I'll have the correct gear ratio. I don't want to vary the pulley ratio and speed up or slow down the auger or the wheels. And I also want to keep the engagement length. The other pulley, the pitch is about 100 thousandths difference, so I need to trim it out to bring the pitch diameter down slightly, and that's what I'm going to show you next. I'm going to trim that in the lathe to tweak that in a little bit. And then the OD is too big, and I need to trim that down in also the side walls. So what I'll do is I'll put this in the lathe on a piece of key stock, or a keyed shaft, and go into this angle here, in this groove, and carve off one side, turn off one side, a slight amount of material until those pins slide down 100 thousandths. on the reading of the micrometer, or close to 100 thousandths. Okay, so everything's pretty much ready to go at this point. I just need to put the idler pulley mounting plate back on this motor here, and the pulleys are set up. They've been modified in the lathe, and of course this is the black one. I repowder coated it blue, for corrosion protection. But pretty much it was a fairly simple modification. All I had to do with this one was trim a little bit off the side of the groove to bring the pitch diameter down by about 100 thousandths. And I had to trim the OD off, and also trimmed a little bit off the sides here too. This pulley I didn't have to do anything to. The pitch diameter was fine, the OD was fine for the most part. It's a little bit bigger, but no big deal. It's not going to cause any interference issues on the snowblower that I know of. So that's fairly simple. The spacing here was straightforward. The mounting holes on this motor are the same distance from the machine mounting surface here. They're the same as the old engine. So all I had to do is take a measurement from here to the center of the grooves, and that was it. So I'll show you one other thing I did here too. And I had to get a different bolt here too. I want to get an actual hex head for this, so I can use a standard socket instead of having to use an Allen wrench. Plus it has more surface area. But what I needed to do here is the shaft on this motor was somewhat shorter than the old motor, and the old pulley had a little bit of overhang, but what I found was the old pulley had this large bushing on it, so it had a large bearing surface on the, when I say bearing surface, what I mean, it bears the stress over a large surface area. So even though it had some overhang, it had this large amount of area to bear the stress on that shaft. However, with this one here, this pulley is much more narrow, and it only sits on the original output shaft by about 3/8 of an inch. So what would happen is this would eventually start wobbling and then walk its way off as the materials start to wear out, and it could get really ugly. If something would catch while the motor was running. So what I did is I turned this little stub shaft here, just this little shaft extension, and I put a little guide sleeve on here. There's a counterbore in the front of this shaft that's unthreaded, and that guide just allows that to stay in place while I install the pulleys. And that provides the extra support this needs. Once the bolt holds this thing in place, it compresses that in place, so there's no way this shaft can move unless it starts actually stretching out that ID bolt or tearing out the threads, which it's not going to do, especially in a snowblower. So that gives it rigidity in that axis, and then the keyway, or the key, gives it torsional rigidity. And also the key is overlapping with the pulley by 3/8 of an inch. So the only way it could really, snap in two is if the keyway would shear at the back of the pulley, and I just don't see that happening, in a million years with this application. So the way I figured the spacing out is I made the shaft and the pulley surface, whenever they're flush, the spacing of the center of the groove would be right on the same as the old engine. So that's what this washer's for. The washer's not to retain the pulley at all. The set screw will take care of that. I've done quite a few of these, and I never had a set screw slip in normal operation. So all that is for is you butt the pulley up against it, and that gives you your spacing for your exterior pulley. And then for the interior pulley, I have 125 thousandths gauge block here, and you just put that between the two pulleys, and that sets the spacing for the inboard pulley. And now the spacing of these two pulleys and the distance from the motor of both of them is the same as the old engine, and this is not going to go anywhere. I'm very confident it's absolutely not going to come off or break or anything of that nature. So other than getting a new bolt and mounting this plate, this thing is pretty much ready to go. I also have to put oil in it, and that's pretty much it. Okay, I have everything just about ready to go here. I want to show you the different tires I put on this. Big difference from the original ones. Here's the original tire here. And they're supposed to be about the same diameter, but you can see these are a little bit taller. These ones were all dry rotted and wouldn't hold air. So I found these Carlisles on here, and the Carlisles is a good tire, and actually they cost the same as this type, so I decided to get these, and these are much heavier duty. They're technically tubeless tires, but I end up running tubes in them anyways because I found that to be more reliable. So I put those on yesterday. Typical difficulty putting tires on, but it wasn't too bad. So I'll get these out of here and then show you the installation. Okay, there's the installation. Actually turned out pretty decent. Of course, here's the pulley setup, and you can see the belt drive on there. Everything lines up. So one other thing I want to show you here too is the Impeller modification that is pretty popular on the Snowblower forums. And all it is a piece of fabric reinforced rubber that's attached to the end of the impeller and held in place with a couple of bolts. And what this does is take up the space between the end of the impeller blades and the housing, and it allows the snowblower to throw wet snow more effectively and keep it from clogging up. It also throws dry snow a lot further using this. At least from the videos I saw, it works pretty well. So this rubber here is a 3/16 or 1/4 inch, something like that. Fabric reinforced like you would see on a conveyor belt. And I have it held in place with these from McMaster Car. They're called truss bolts, and they're stainless steel, 1/4 inch thread. On the box it says sidewalk bolts, but they have a very low profile and a wide head, to help support the rubber, and also to keep the snow from building up like you would have with a higher bolt. So I beveled the back edge here too. I put a bevel there to keep snow from building up, but this is supposed to work really well. So I figured I'd try it. They interfere quite a bit right now with the housing. They rub pretty heavily, so people said that it wears in pretty quickly, so I'll see. So I left a chute off here to show you guys the operation of this impeller here briefly. I put some gas in the motor and it started right up, and I'm going to start it here to show you the impeller. It makes a lot of noise right now until that modification, till that rubber gets worn in. But I wanted to show you this. Okay, let's start it up here. Maybe. Oh, I had it shut off. Okay. hell? It's going to make a racket for a while until that rubber gets worn in and wears out a little bit around the edges. But that's supposed to work really well. And I'm going to put the rest of the covers on it and give it a test drive here one of these days. We have some snow, but not enough to run the snowblower on yet. Well, I'm thinking this is going to be a perfect opportunity to use that snowblower. This is first major winter storm of this season, and it's putting down a lot of snow. We're in the middle of a winter storm here in PA. Yesterday we didn't have any snow before it started. It was sunny. There was like maybe a dusting on the grass. Now we have, you can see there, about a foot of snow, and this isn't over with yet. I can do more with this snowblower now on half throttle than I could with the old engine on full throttle. I'll show you here how I cut through this snowbank. This thing is literally up past my knees. Of course, this is where the plow plowed it in. But we went from having no snow to piles 6 feet high now. That wasn't too bad. Could have been a lot worse, like if I was using a shovel. But everything works pretty good on that, actually really well. I didn't go above half throttle. I don't really need to with that bigger motor. Just over revving it doesn't seem to make the snow go any further. I found out it just kind of just revs up higher. But I put the rubber impeller modifications working really well. It seems to throw snow, I don't know, maybe twice as far. I don't really measure it, but it's working really well. It does make some noise until those things wear in. The good part is it cleans the rust off the inside of the impeller housing. So anyway, these guys, I got to clean the car off a little bit more before I head up to my shop. But I need to carve out another path here, clean off a sidewalk across the yard. But it worked out pretty good. I have no complaints so far. I try to keep most of the swearing off camera, but this thing starts up, put the choke on, half throttle, starts up in about 3 pulls consistently. Those new lug tires, they're self-cleaning for the most part. Holy cow. Man, that's one thing about running a snowblower on this mountain is we're a little over 2,000 feet here, and I don't know what causes it, but the wind direction changes constantly up here. So you set the chute for one direction and it blows back in your face. You set it for the opposite and the wind changes and still blows it back in your face. It's kind of like campfire smoke.